Hello class, welcome to our lesson today dealing with section 7.3. This is estimating a population mean, and you'll notice in this part of the section it's sigma is known, so the standard deviation of the population is known. What you'll look at in your homework is the questions are kind of flip-flopped. They do the unknown ones first and then the known ones second. I like to do the known ones first just because they use the same z-score idea that we did with proportions, excuse me. So if you notice there's some questions you're not sure how to find some of them because they use a different variable. It's called the t-table as opposed to the z-table. It's probably because it's from that other lesson that we'll look at later in this semester. Okay, the first thing that we need to make sure of is that the sample mean, which is x bar, whatever the mean of the sample is the best point estimate for the population mean. Much like p hat was the best point estimate for the proportion. For everything that we're looking at today, the standard deviation of the population is known. The last bullet point here says that you have to have a normal distribution, so you have to know that the information that you're getting this from is from a normal distribution of a data set, or that n is at least 30, which is basically the central limit theorem. One of those assumptions has to be true, otherwise whatever we're going to look at today would be irrelevant and actually not helpful in terms of a final response. What you'll notice here is that the formulas, there's a margin of error formula. Similar idea, this z-score is that whatever the z alpha over 2, so whatever the z-score is for like 90, 95, 99%, times the standard deviation divided by root n. That will find the margin of error. And then the confidence interval is the point estimate, which is x bar, plus or minus the margin of error. So really the idea is very similar to what we did with the proportion ideas before. These numbers will be much larger. The proportion ones, the margin of errors were always small because they have to be less than 1 to be a probability or a proportion of the whole group. These numbers will be larger because the means can be larger numbers, and so what you'll probably notice is that will happen more so in these situations. Don't forget the interpretation for confidence intervals is that you're 95, in this case 95% confident that the actual mean is between the two numbers 164 and 180. Remember, I can't say there's a chance of anything that falls between that because it's either there or it's not there. But what I'm saying is in between these numbers, I'm 95% sure that the actual mean, the true proportion or true mean of the population is between those two numbers. Okay, so here's an example. The average weight of 40 men is 172.55 pounds. So first thing to notice from the first line is that n is 40. And this 172.55, that's x bar. That's the sample mean. Find the 90% confidence interval, given that the standard deviation of weight of men is supposed to be 26 pounds. So they gave you some prior knowledge, which means that's sigma. And then the z-score, since it's 90% confidence, with the z-score would be 1.645. I find the margin of error, take the z-score times the standard deviation divided by the root of 40. I get 6.76. Notice here for this question, n is 40, so that's a good sign. I can do this idea. And it also said that it had it doesn't say if there's a normal distribution here. So it's important that we had at least 30 in our data set. The 90% confidence interval is the point estimate, which is x bar, 172.55, plus or minus the standard deviation. I could write it this way with this plus minus idea. I tend to write it the second way, showing kind of the low and high end kind of as like an interval. Either way is acceptable on a test or a test question. Your homework, though, may be specific in the way that it's set up. So you want to make sure you're paying attention to that. The other thing is whatever you round to, you got to be just careful that you're not rounding these numbers off too early. It shouldn't matter if you're rounding to 2 places on the confidence interval. 2 places should be plenty on the margin of error. The final conclusion to this one would be that we're 95% confident that the true weight of men is between, 90% confident that the true weight of men is between 165 and the 179 numbers. That's what that would be saying for this situation. The next thing, similar to proportion questions, we went through how to find a confidence interval, and then we have to be able to work backwards to figure out how many people we should ask a question to. All this is solving the margin of error formula for n. Notice here it's everything squared, and the reason is because the square root pieces were in kind of different spots. So you'll take your z-score times the standard deviation divided by the margin of error, square it. Same rules apply, you still round up. in order to figure out what sample size you need to ask for any particular population. Okay, this one's about IQ scores. Assume prior studies show the mean is 100 and the standard deviation is 15. Again, the mean being 100 is kind of irrelevant here if we're trying to find the sample size. So when we're looking at this situation, what I have done to make sure of is find the sample size that would be necessary in order to figure kind of out the situation. So I want 95% confidence. So that would mean I want my z-score to be 1.96 times the standard deviation. And it says we want the population or the mean to be within 3 IQ points. Now, for the proportion questions, when it was a percent, we had to make it a decimal. That is not the case for these questions because these are just numbers. This is 3 IQ points. We don't want to make it 0.03 IQ points. It's just 3. So you have your z-score times the standard deviation, then divide by the 3 IQ points because that's the margin of error. Anytime you see within so many points or within so much, that's the margin of error, and square it. You should get 96.04, and always round up. Even if it's 0.04 like this one, you still round up because you have to make sure you cover enough people in order to be successful for your sample size. The next one is very similar. The difference is it's 90% confidence and within 4 points. So notice here, instead of 1.96, I've got 1.645 times the same standard deviation, now divided by 4. Notice how much smaller this is. This is 38.05, which rounds to 39 when I round up. I went from the confidence of 95 to 90, and I went from 3 to 4 IQ points. So that just widened the gap of options I have. I'm casting a bigger net, and if I want to cast kind of or I don't want to be as confident, I can kind of say, well, I have to ask less people because I don't really care as much about the answer, and so I can just make the numbers a little bit wider and then, or a little bit smaller. It kind of depends on your situation. So I have to ask less people because I have less confidence. So I don't need to be as sure. And so I can ask less people the question, just realizing that, oh, I'm not as sure as I was before. Compare this with 95, it's even more. If it was 99, it'd ask even more people because you're basically saying I want to be more sure, okay, than what I would with a 90 or 95% confidence interval. If you don't know sigma, the goal, there's a few goals. Number one, see if there's other studies that have been done on your topic and see if there is a standard deviation that's known according to whatever topic you're talking about. The second bullet point may be used sometimes in your homework, but I would never suggest this just because of technology nowadays. The range rule of thumb would say take sigma and just make it the range divided by 4 because the standard deviation is always 2 kind of away in both directions, so it's basically split up into 4 equal sections. I wouldn't suggest doing that unless it tells you to in a homework assignment. I'm never going to ask you that on a test question because we shouldn't be using that idea. The best idea is the third bullet point, which is if we don't know sigma, well, we collect some data, find a sample, find the sample standard deviation, and then use what's known as a t-distribution table because we're going to be less confident compared to our z-table. That's what the next lessons are going to be about, is using that idea, find a sample, and then do the t-distribution. If you think about technology, maybe 50 years ago, this would have been a lot more challenging because technology wasn't as quick to do a lot of number crunching. But nowadays, because of how quickly things can be done, the third bullet point should definitely be used if we can't find a previous study. So we're going to be looking at that as we move into the next couple lessons. Your homework will have questions that deal with that topic. Obviously, feel free to kind of skip those until we get to our next lesson. But you should be able to skip around, and there should be a decent amount of z-score questions. Okay, this says, if possible, find the confidence interval. So we're just going to go through these last 2 questions just to recap how to find confidence interval. This says the distribution of the data does not appear to be normal. So that's a red flag. That's a red flag saying, well, I may not be able to do this. But it's okay here because n is 50. Okay, so n is 50. 95% confidence, 1.96 for z, times standard deviation divided by root n. I should get 18.85. And then this confidence interval would be my point estimate, which is the mean, 677, plus or minus the margin of error. And then that range of answers, remember what that's saying is we are 95% confident that the true FICO credit score is between this 658 and 695 number. You're going to have to write those things out on test scenarios, like the end wording and the sentence like I just mentioned. Your homework is more multiple choice ideas with that, so you want to make sure you're paying attention to that, but also make sure you're able to write it on your own. The next one, say this is time before the circuits go out on a calculator. Maybe this has happened to you, hopefully not on a test day, but your calculator just stops working. This is 99% confidence, so 2.575 for that, times the standard deviation of 18.6 divided by the square root of 25 in this case. You should get 9.85, and then the confidence interval will be 112 plus or minus that 9.85. So we are 99% confident that the amount of time before the calculator breaks is going to be between those two numbers. And so the true average or amount of time should be between those two. We're 99% confident that it is. Remember, it's not a 99% chance, it's 99% confidence. There's a difference between those wordings. One thing that you need to look at for this question, though, in particular, is it says the data does not appear to be normal. This is a problem because I only asked 25 people. So we did all this work. It looks great. Everything's right mathematically. But it actually doesn't make sense to write this out because we can't use the theorems that we've been doing. You have to make sure that it's a normal distribution or n is at least 30. So this only has n 25, and so because of that, we can't say even this conclusion that we just came up with is invalid. Okay, so you got to be careful on that. Some of your homework questions may have that. You want to make sure you're paying attention to if you can even do the process. And that's one thing you want to check. It's very quick. Just see what the sample size is, see if it's a normal distribution. Those two things will dictate whether it is or not. Please make sure you have the margin of error formulas written down. Make sure you have the sample size questions formula written down. These homework questions, once you get into the routine, I think will be a lot easier, but you want to make sure you work a little bit ahead on some of those to ensure that you're on the right track. Have a good day, everyone.